student, now this is very important section. You will say that sir, each and every section you are saying very important, but beta, it is really too much important section. It is because the next 3 period will be based on this period. That is this content. This is very important content. What chemical properties? That is how the aldehydes and ketones behaves chemically. So in very early period I told you the chemical property or the chemical behavior actually depends on the electronic structure of any compound. Electronic structure, that means what? In electronic structure you can see here the feasibility of breakdown of bond. That is which bond can be easily break down. Getting? And this can be seen only by the electronic structure. Getting? Aldehydes and ketone, they consist of what? Carbonyl group. Now, what is carbonyl compound? This is called carbonyl compound. Getting? Say carbon and double bond oxygen. Student, you know that if there is double bond, that then already the compound become highly unstable. Okay, even if there will be no double bond, whenever you can see here the oxygen being very more electronegative, very high electronegative. Therefore, the partial shifting of electron takes place. Thus, the oxygen acquires fraction negative charge, while the carbon acquires fraction positive charge. Are you getting here? But if there is a presence of pi electron pair, you know that due to pi electron pair, the electron repulsion between carbon and oxygen is very high. Why? Already there is a sigma electron pair and one more electron pair is there, which we are giving the name of pi electron pair. And you know that the pi bond are weaker bond as compared to sigma bond. Therefore, one of the bond can be easily break, and when it will break, the electron pair will transfer to the more electronegative atom. More electronegative atom, that is its attraction force, nucleus attraction force is very high as compared to attraction force of carbon. Therefore, the electron which is negatively charged is attracted by an atom with having higher nuclear attraction force. Thus, after this change, the species become C, and now what? O. C and O. That means what? Now, due to complete transfer of electron pair, now the fraction negative charge will completely convert into negative charge, while the fraction positive charge will acquire a completely positive charge. That means what? That means now in the compound the carbon become electron deficient, that is highly electron deficient, while the oxygen becomes highly electron efficient. So here carbon is electron deficient, while oxygen is electron efficient. And now if the electron deficient and electron efficient type of species are present in a compound, then it will become very high reactive. Therefore, the carbonyl compounds are highly reactive in nature. Which type of reactions are possible in such a way? Okay, here with in O minus charge any plus charge can attack, and in C plus charge any negative charge can attack. That is what a compound having electrophile and nucleophile both can attack on this reaction. So if that compound will react with these species, then simply the addition reaction is possible. Therefore, carbonyl compound gives addition reaction. Getting? Addition reaction. Now, I am not giving the name of addition reaction, that is which type of addition reaction is possible. So students, look at here. C, okay, and there is O. There is complete negative charge and there is complete positive charge. So if any species like say A and B, or say Nu and E. What is the meaning of Nu, E and E? A compound is formed by two species, E that is electrophile and Nu that is what? Nucleophile. Getting? So the nucleophile being positive charge will attack on this oxygen atom, and the nucleophile being negative charge will attack on carbon atom. That means what? That means now the nucleophile and electrophile will simply added to the carbonyl compound. Thus there is the formation of, now there is what, O, and in this O electrophile will attack. Okay, I am denoting it by plus charge. Electrophile will attack, while in carbon there will be the attack of nucleophile. This is called addition reaction. But actually beta, this addition reaction is known as nucleophilic addition reaction. Nucleophilic addition reaction. Okay, student, here electrophile and nucleophile both are added simultaneously. Getting? But why the reaction is called nucleophilic addition reaction? Why don't it is known as nucleophilic as well as electrophilic addition reaction? Okay, so there is the question, why? Okay, it is so. That is, why don't it is called electrophilic addition reaction? It is because when nucleophile attack, this is what, minus charge, attacks, the stereo of compound gets changed. The stereo that is configuration. Okay, or you can say stereo configuration. Is changed. How it is? Earlier it was what? sp2, but now it become sp3. That is what? sp2 it become what? sp3 hybridization. While when the electrophile is getting attacked, there is no change in the configuration of central atom, that is carbon. But here there is change in the stereo configuration or overall hybridization state. You can also call it what? Even hybridization state. Even we can say hybridization state, of central carbon is changed due to attack of nucleophile. Attack of nucleophile. Therefore, this reaction is known as nucleophilic addition reaction besides of electrophilic addition reaction. Electrophile do not changes the stereo or the hybridization state of carbon. Here earlier the carbon, here what? sp2 hybridization, but now this carbon become sp3 hybridization. Therefore, the reaction, when we will read in the next content, will call nucleophilic addition reactions besides of electrophilic addition reaction.